Yeah, hello everyone. So in this video, I'm going to discuss some more problems of continuity and partial derivative. So first question, we are having fz equal to 2x square plus 3y power 4. We have to check continuity of this function 2x square plus 3y power 4. So here you can get confusion. I have written here f of z. So you can think here imaginary part is 0 and real part is given 2x square by x square plus 3y power 4. So we have to check continuity. So we have to check continuity of this function at z equal to 0. So this we can write. We can take first our target is to calculate limit of this function at z equal to 0. If limit will exist, then we can go for continuity. If limit does not exist, we can stop our calculation and we can claim that function is discontinuous. So let us calculate limit of this function. Limit z tending to 0, 2x y square divided by x square plus 3y power 4. So we know that we can take here z equal to x plus iy. So if z is tending to 0, this means x also has to be tend 0 and y also has to tend 0, because if z is tending to 0, so this we can get limit x tends to 0 and y tends to 0. So this we can take in place of limit z tending to 0, we can write limit x tending to 0, y tending to 0, 2x y square divided by x square plus 3y power 4. So again, as I discussed in previous lecture, we can choose some different path. So first path we can choose along x-axis. Along x-axis means what? This will imply y should be what? 0. So this limit we can get. So y is exactly 0. So limit x tending to 0. Y is 0, then you will get 2x into 0 and divided by x square plus 3 into 0. So finally you will get 0. So along x-axis we are getting limit 0. Similarly, along y-axis also you can check limit is 0. Along y-axis also you can limit 0. But how to choose a path? What kind of path we can choose such that limit of this function we should not get 0, so that we can claim the function is discontinuous. So what path can be chosen so that the limit of this function is different from 0? So you can look at here. What is, if I will ask you, what is power of numerator and denominator? So by helping by considering degree of numerator and denominator, easily we can get idea what kind of path we can choose. So if you will see here, power of numerator is power of x is 1 and power of y square is 2. So total degree is 3 and denominator is you are getting degree 4. So what path we can choose so that power of numerator and denominator same? So if I will choose path x equal to y square, if I will choose path x equal to y square, then power of numerator and denominator will be same. So third path we can choose. The second path you can choose along y axis, and again we will get same 0. If I will choose along x equal to y square, if I am choosing this path, because we can choose, because how you will get to know that this is correct path, because if I will take y 0, then x we are getting 0. If x is 0, then y is also 0. We cannot choose here y square plus 1 or y square plus 2 or any other path, because if x 0, then y should be also 0. So along x equal to y square, then what you will get? Limit. Now this x tending to 0, y tending to 0, this is simultaneous limit, both tending to 0 simultaneous. But if you will choose x equal to y square, then this limit will be converted into one directional limit. So you will get limit, now y tending to 0, x equal to y square. So 2x value y square into y square and divided by x square plus, sorry, x square is y square. So x equal to y square we have taken. So x square will be what? Y power 4. So this we can get y power 4 plus 3 y power 4, and this is what? 2y power 4 divided by 3 plus 1. So 2y power 4 by 4y power 4. So y power 4, y power 4 cancel, and then you will get limit 1 by 2, which is not equal to 0. So you are looking here how this path I have taken x equal to y square, so that power of numerator and denominator, if you are able to make same, then immediately you can prove that this function is discontinuous, because limit must be unique and limit should be finite. But here if you will see here, along x-axis, along y-axis, we are getting limit 0. But when I have chosen along x equal to y square, limit is different from 0. So immediately we can say this function is discontinuous at z equal to 0 or at 0 comma 0. Z equal to 0 means, because z we are considering x plus iy. So if z is 0, then x and y both 0. So this function, we can say that this function is also discontinuous at z equal to 0. Again, we are having next problem, fz equal to x square y power 4 divided by x power 4 plus y power 10. If z is not equal to 0, z equal to 0. So we can we have to check again continuity of this function and whether partial derivative will exist. We can check both, whether this function is discontinuous or continuous, and what about partial derivative at 0 comma 0. So we can take anything. So first, let me calculate continuity of this function. So again, I can explain here, I can remind you what is power of numerator 5 plus 2, 7, and what is power of denominator 10. So numerator power is 7 and denominator power 10. So what path we can choose so that power of numerator and denominator can be made equal? So I will give you one path, but first you choose along x-axis, along y-axis we can take. So if I will choose limit along, if I will choose path along x-axis, so along x-axis, y must be 0. Y 0 means what? We can get only one limit, x tending to 0. Limit x tending to 0, x square, and y is 0. So y power 4 0 divided by x power 4 plus 0. And this is again 0. Don't get confusion. This is 0 by 0, because before this limit tends to 0, this resultant should be 0. So x tending to 0. So this you will get 0. Some students get confusion. This is 0 by 0, but this is not 0 by 0, because numerator is exactly 0 and denominator is tending to 0. So if numerator is exactly 0, then 0 divided by anything, we can get 0. So along x-axis, we are getting limit 0. Similarly, you can see along y-axis also, x should be 0. So x 0, then again you will get limit 0. So some student, after choosing two paths, they can claim that this function is continuous, but actually this function is not continuous. So how we can choose path so that power of numerator and denominator can be made equal? So if I will choose here, if you are looking here, x square and y power 5, power numerator power is 10 and numerator power is 7 and denominator power 10. So if I will choose x equal to y power 4 or x square equal to we can choose x square equal to y power 5. X square equal to y power 5, if you will choose, then what you will get? Y power 5 into y power 5, y power 10. And here, because denominator is x power 4, so x square, if I will take y power 4, then x power 4, y power 10. So now degree of numerator and denominator can be made equal. So we can choose next path. Second path we can choose along along x equal to x square equal to y power 5. X square equal to y power 5, then what you will get? Limit y tending to 0. X square is what? Y power 5. So you will get y power 5 into y power 5 and divided by x power 4. So if x square equal to y power 5, then what will be x power 4? Y power 10 and plus y power 10 is given. So you are looking how easily we made the power of numerator and denominator equal by considering this path. So y power 10, y power 10. Again, you will get this limit is what? 1 by 2, which is not equal to 0. So immediately we can claim that this function is also discontinuous. This function is also discontinuous. What about its partial derivative? Yeah, easily we can calculate its partial derivative also. We can calculate its partial derivative dou f by dou x at 0, 0. Because why I am calculating at 0, 0? Because this function will create problem at 0, 0 only, and other point easily you can calculate. So what will be dou f by dou x? In previous class I explained this is nothing but what? Limit s tending to 0. Dou f by dou x means what? Derivative changing along only x direction, and dou f by dou y means changing along y direction. So limit x tending to 0, this you will get f h comma 0 minus f 0 0 and divided by h. So this is what? Limit h tends to 0. Limit h tends to 0. So now you can see here, if I will calculate h comma 0, h comma 0 means what? X component h and y component 0. So you will get 0. And here z equal to 0 is what given? 0. Z equal to 0, value of function is given 0. So this we calculate limit s tends to 0. F h comma 0 is what given? We are getting 0. Minus f 0 0 is also given 0 divided by h. And this is again 0, not 0 by 0 because numerator is exactly 0. Similarly, dou f by dou y, dou f by dou y at 0, 0. This also we can calculate, and this equal to limit k tends to 0 and f0 comma k, f0 comma k, f of 0 comma k minus f0 0. Why 0 comma k? Because in dou f by dou y, changing will happen only along y direction. So this is divided by k, and again this limit will come out 0. So this again, this equal to limit k tends to 0 and 0 minus 0 by k, this is again 0. So one more thing I want to clarify here. Some students they might be thinking that f0 is how f00 is 0. So you cannot calculate f00 value from the given function, because if you are putting here x and y 0, so 0 by 0. And here if you will look at here, it is clearly mentioned z is not equal to 0, then only we can choose the given function. If z equal to 0, then value of function is what given? 0. So we cannot calculate value of function at 0 0 from the given function, but here because given z is not equal to 0, if you will see domain of the function, so we cannot take z equal to 0. So in this question, partial derivative will existing, but function is not continuous. One more example. Third example, this f of x y is given. F of x y is given. This is x square minus y square and divided by x square plus y square. Xy not equal to 0, not equal to 0 comma 0, and this is 0 if x and y are 0, comma 0. So again we can check continuity of this function. So let me take first along x-axis, along x-axis, along x-axis, y should be what? 0. This you will get limit x tending to 0, y equal to 0, then we can get x square and divided by x square, which is come out 1. Similarly, we can choose along y-axis. Along y-axis, what will be limit? This we can take along y-axis. Along y-axis, this will imply x equal to 0. X equal to 0, then limit y tends to 0. If you will look at here, now limit is only unidirectional, only x is tending to 0 and y is tending to 0, because if you are choosing along x-axis, then y is exactly 0. And if you are choosing along y-axis, then x will be exactly 0. So limit y tends to 0. This you will get minus y square by y square, which is equal to what? Minus 1. So here two paths are sufficient to prove that this function limit does not exist. So this function is also not continuous at 0, comma 0. And similarly, you can calculate partial derivative at 0, 0. Yeah, I will calculate what will be partial derivative at 0, comma 0. So dou f by dou x at 0, comma 0. This will be what? Limit s tends to 0, f of h, comma 0 minus f 0, 0 and whole divided by h. So h, comma 0 will be what? This you can calculate from the given function. So function is given x square minus y square. If y is 0, then you will get h square by h square. So this we can get limit s tends to 0. F h, comma 0 will be what? H square by h square 1 minus 0, and this divided by h. So this will be what? So this partial derivative, this, because h tending to 0 and the numerator is finite, so you will get what? This limit is what? Infinite. Similarly, dou f by dou I at 0, comma 0, this will be what? Limit k tends to 0, f of 0, comma k minus f 0, 0, and this equal to what? Divided by k. So again you can calculate this time 0, comma k will be what? X square 0, y square k. So again we can get minus k square by k square. So again I will get minus 1. So this you can write this equal to limit k tends to 0 and f 0, comma k will be what? Minus 1 minus 0 by k, and k is tending to 0. So because the denominator is tending to 0, so this also you will get what? Minus infinite, because minus 1 is given. So here you can see partial derivative is also not existing because we are getting infinite, and function is also discontinuous. So now I will give one a shortcut method how to check whether the function is continuous or not continuous. This is not any standard result, but you can apply it. If power of numerator, if you are having any function in which power of numerator is always greater than denominator and denominator is not equal to 0, here I will write if power of numerator, if power of numerator is greater than power of denominator, and denominator and denominator is not equal to 0, then function is always continuous. This is not any standard result. Just I am giving you roughly idea. You can verify. So if I will show you this concept. If power of numerator is greater than power of denominator and denominator is not equal to 0. So in general, function is always continuous. So if you will look at here, in this question, what is power of numerator? 3. Power of denominator is 4. So power of numerator is less than power of denominator. So always function will be discontinuous. In this question also you can observe power of numerator is less than power of denominator. And in third question also you can see power of numerator and denominator equal 2 and 2. So if you will choose power of numerator is greater than power of denominator and denominator is not equal to 0. If denominator equal to 0, then what will happen? I will give one example. If suppose we are having this function, we have to calculate limit. If we are having fxy equal to x cube minus y cube, x cube minus y cube or x cube plus y cube, you can choose any function, divided by x plus y. And again same thing, x and y not equal to 0 comma 0. And here if 0, if both x and y are 0, 0. So if you will look at here, power of numerator is greater than power of denominator. So first criteria is fulfilled, but denominator should not be equal to 0. What about denominator x plus y? In this question, if you can choose any path, always you will get limit 0. But when you will choose limit, when you can choose path along x equal to if I will choose this path along y equal to minus x. If I will choose this path along y equal to minus x, then what will be limit? Limit x tends to 0, x cube minus y cube will be what? This y equal to minus x cube. So you will get minus x cube. And here y equal to minus x. So y equal to minus x, then this will be what? Minus x plus x, so 0. So this will be what? Minus x plus x. So here this you can get limit does not exist because this is coming 0 by 0. So this type of function, because why this function is discontinuous, because when you are choosing y equal to minus x, denominator will become 0 and answer is coming out to 0 by 0, or sometime you will get plus infinite. But if I will change this x plus y, if I will change x square plus y square, in same question, if I will change the question by x square plus y square, then what will happen? If this question, if I will change x cube this question, if I will change x square plus here x square plus y square. So this question you can see here power of numerator is greater than power of denominator also, and denominator will never 0 because x square plus y square, this only it can be made 0 if x and y both will be 0, then only this equal to 0. But because this is a simultaneous limit and we have to convert in unidirectional limit, so this is not possible. So if you are trying to make x square plus y square equal to 0, so in this case x square will be what? Minus y square, and you will get some imaginary path like that. So this function is always continuous because power of numerator and is greater than power of denominator. But how you will prove this question is continuous? There is only one method, by epsilon delta method. If you cannot claim that because limit of this function along every path we are getting 0, but this is not correct way because we are having infinitely many ways. So we cannot claim that along infinitely many ways this function limit coming 0. So just only you can get idea when function is continuous and when function is discontinuous, and this is not any standard result, but you can apply, you can get your approach that if power of numerator greater than power of denominator and denominator cannot be equal to 0, so function 99%, then those this, if any function will satisfy this criteria, so it will be continuous. Some student also they might be thinking, if again if I will come back to previous problem. Some student they can also think here, if I am putting here x cube plus y cube by something x plus y, if I will choose, or x minus y you can choose. So some student are thinking here a cube plus b cube we can apply, and for example limit, if you have to calculate limit x tends to 0, y tends to 0, and here you can apply a cube plus b cube, so you can get here x plus y something, and here in bracket x and x square plus y square, this x square plus y square plus 2, and here denominator x plus y will be cancel out. So this approach is also incorrect, because here x is also tending to 0, y is also tending to 0, so you are cancelling out 0 by 0. If you are, if you can write this formula, you can verify this is correct or not correct. X square plus a cube plus b cube in one bracket, a plus b, a square plus b square plus something here, and here divided by x plus y. So just I am giving you roughly idea, this a cube plus b cube you can verify yourself. So here if I will cancel out this x plus y, x plus y, so this is not correct approach, because x is also tending to 0, y is also tending to 0, and here 0 by 0 we are cancelling out. We can cancel out here 0 by 0, and here x is also tending to 0, y is also tending to 0, so you will get finite limit. But this is not correct approach, because 0 and 0 we cannot cancel out. So this function a cube plus b cube, if you are applying, this is correct wrong approach. So final conclusion is this function is discontinuous, even though power of numerator is greater than power of denominator. Why? Because if I will choose y equal to minus x, so limit of this function, we can get either 0 by 0, or sometime we can get infinite. So now I hope concept of partial derivative, continuity, and how to choose different path, and when we can make power of numerator and denominator equal. So these concepts should be clear to you. And next video, now I am going to start about CR equation and differentiability, and then analytic function. Thanks, and keep watching.